Hey everybody, welcome to your Algebra 1 3.2 online lesson. We're going to just do part of 3.2 today, and we're going to focus today on slope-intercept form. There are basically three forms of linear equations. I think this is the most popular and the one that you'll see the most, so I just wanted to start with that today. I'm going to show you a bunch of examples, basically some exercises from 3.2, so it would be most helpful to you to have your textbook with you. And if you can, open up to 3.2. 3.2 begins on, let's see, page 225. So slope-intercept form. What is slope-intercept form? Well, the name of this special form of a linear equation gives it away. You've got a slope, m, and you've got an intercept. And more specifically, it's the y-intercept. So that is slope-intercept form. The slope is always associated with the linear term, which is the x to the first. It's also known, it's the coefficient of x, we could say. So example 1, the first example that I'm going to show you is number 5 in your text. So if you can look at number 5, it's always really important to follow along and read the instructions. So I think this is most helpful when connecting all of these concepts together. Number 5 says, write in slope-intercept form y equals mx plus b the equation of the line with the given slope and y-intercept. So negative 2/11 is the slope, and the y-intercept is at 0, 5. Remember with the y-intercept that the x value is always 0. So b is the second part of that coordinate. Okay, so you could even think of the y-intercept as our 0b in that form when you're looking. So this negative 2/11 goes in right in front of x, as you can see, and b is the 5. Once again, you can think of the y-intercept as 0, comma b as a point. And so then we just fill it in. The coefficient of x is negative 2/11. That's the slope. Don't forget your x. That's a common mistake students will forget. If you forgot your x, then you would have a constant. You would have a horizontal line because it would just be a number, right? With a 0 slope. So I would like you to try on page 226, there's a self-check, and I would like you to try self-check 1 now. So you can pause the video and try self-check 1 and check your answer at the back of the section. See how you do. Okay, we're moving on to the next example. It's like example 2 and example 3 because we're going to graph it. Let's see. So we're going to try number 12. And if you read the directions to number 12, they say use the equation of each line to determine by inspection the slope of the line, determine by inspection the y-intercept, and graph the line using pencil and paper. So the equation of this line is negative 5/2 x plus 3. Well, it looks like I changed it to plus 2, which is fine. We're just going to keep it like that. So you can call it 12 modified. I had actually made this video before and I wrote it all out and I was talking along and I realized that the audio had not gone, for some reason, been recorded. So I'm talking as I go with this instruction. So if it seems a little disconnected, that's the reason. but it's kind of nice in a way to look back. So see how I'm circling the negative 5/2? That's the coefficient of x, so that means that will be the slope. And the b is the constant term, so that's 2. So once you have that, you've identified your slope, you've identified the y-intercept. Now we're going to graph it. And once again, remember number 12, this is kind of 12 modified because I changed the y-intercept to a 2 instead of a 3. So I'm just drawing on a piece of graph paper, and it's really nice to use graph paper for this, especially when you're using the slope triangle. So from B, I know that my y-intercept is at 0, 2. So I'm going to start there. You always start at the y-intercept. So you go up 2, and then with the slope of negative 5/2, when you create your slope triangle, remember you always work left to right, okay? That negative 5 tells me I go down 5, but I'm going over 2. Which way do I go? Do I go over to the left or over to the right? I always work left to right. So I'm starting at that point, 0, 2, and you can visualize it. I'm going down 5 units. 1, 2, 3, 4, 5, and I'm going over 2 units. Then I connect, and it's great to use a straight edge. Haven't quite figured that one out yet. And just if you draw the little arrows to connect it, that's what I recommend. It looks nice, so it shows that it's continuing on the domain, thinking about all your inputs, all real numbers. And please label the y-intercept and one other point on your line. And I would label the one that you found from your slope triangle by going down 5. So we're going down 5, which you start back at the origin, and then you're at going down 3 more units. So that's at negative 3, and you're going over 2 units, so it's 2, negative 3. So that's the equation of the line. And this is the graph for that particular function. And I did mislabel that, so that's 0, 2. I shouldn't have put 0, 4, it's 0, 2. So note that correction. Okay, next example. Example 4. In example 4, the main idea for example 4, if you look at example 4 in your book, is using a table of values to write the equation of the line. By the way, go back to self-check 2 and 3 and try those out on your own. You can pause the video right now. I would do that and see how you do. Even just by looking at it and practicing, it makes such a big difference if you try it on your own. So with number 20, I'm just writing down the values right now of number 20. Number 20 is, as you can see, the table. I don't even write down all of the values. I get down to 0, 3, and I know that that's enough. Think about what 0, 3 might be. Because remember, this is a linear relationship. It says that in the instructions. It says, use the given table of values for a linear function to determine the following. So this is our linear function. And I know that it's a linear relationship. So when I'm checking for the first one, the change in x for each of those points, from negative 3 to negative 2, what do? I add 1, okay? And from the next 2, I add 1 again, and I'm adding 1. It's important that you notice if you're going up or down for these when you're calculating the slope in a table. And we did this in 3.1 as well. So with B, the change in y, the difference from 18 to 13 is, looks like I'm going down. Do you see how the y values are decreasing? So that's a good note that this is going to be a negative slope, right? So from 18 to 13, I have to take away 5, subtract 5. So that's a minus 5 or a negative 5. Right there, once again, negative 5 and negative 5. So the change in y for this is negative 5. C, they want us to calculate the slope of the line. the slope of the line, don't forget it's the change in y over the change in x. Rise over run, if that helps you. Remember, rise is think vertical. So that's the y-axis. So negative 5 over 1, or you can write it as negative 5. The slope is negative 5. D, it says the y-intercept of this line. Now what value, what input gives you 0? That's what you're looking for, because the y-intercept, the x is always 0. 0, 3 is the right in this, you can see it in the table. Okay, and part E is the equation of this line in slope-intercept form. So here we go. We've got our b, so b is equal to 3. We have our slope. It's helpful to just write out the equation, mx plus b. If you get confused, then you know that the m goes with the x term, the linear term, and the constant is 3. And that is the equation. So please practice self-check 4, all self-check 1 through 4, and we'll continue practicing this on Monday. Have a wonderful weekend, and I hope you guys enjoyed the video.